We're back on page 74. We're going to work the next couple examples. They don't give us a picture on these, so we're going to have to draw our own picture. The diagonal of a square. Okay, so there's my clue, what kind of geometric figure this is going to be. This is a square, which means I've got 4 right angles and all my sides are the same length. And it says that the diagonal of this guy is 5 radical 6 long. So we can just go ahead and draw that in. He's 5 radical 6, and we know his sides are both the same. We don't know what they are, but they're the same. So I'm going to use x for the length of the sides. And that's what they're asking us to find. So we can use the Pythagorean theorem because we have right triangles here, and we have our 2 legs, x squared plus another x squared equaling 5 radical 6. That whole thing squared. So now we're going to solve for x. We have 2 of those x squares. Don't change that exponent. We're just combining one x square here and another one here. And when you go ahead and square this guy, you're going to square the 5 and get 25. And you're going to square radical 6 and get radical 36, which is 6. So now this is looking a little bit more friendly. 2x squared is equal to 150. Divide both sides, and you get x is equal to 75. X squared, sorry, is equal to 75, and we'll clean that up a little bit. X is equal to the square root of 75, which simplifies further to the square root of 25 times the square root of 3, which is 5 radical 3. So each one of these sides is 5 radical 3 long. All right, let's do the rectangle. The rectangle measures 5 by 2 radical 5 feet. Okay, so a rectangle again is going to have some right angles, and that's going to help us use the Pythagorean theorem. 5 and 2 radical 5, and they're asking us to find the length of the diagonal. So essentially they're asking us to find the hypotenuse across from the right angle. So 2 radical 5, 1 leg squared, plus 5 squared is going to equal our hypotenuse, our x squared. So if we want to label the hypotenuse x, it would look like that. And now we're just going to go solve and see what we get. So 2 squared is 4. Radical 5 squared is 5 plus 25 equals x squared. So that's what? 45? 20 plus 25 is equal to x squared. Square root of both sides, we only want the positive root. That's the square root of 9 times the square root of 5. So that becomes 3 radical 5. And that's as simplified as we can get. And that's our diagonal. Next page. So now we're working with a triangle. And it doesn't look to be a right triangle. And it's not a right triangle, but this height splits it into 2 right triangles. So we're going to be able to use it, the Pythagorean theorem as well. So it says this triangle is an equilateral triangle with each side 10 units long. So this is 10 and this is 10, and it says the height is a line of symmetry. So it splits this third side of the triangle in half, making each one of those sides 5 to be able to add up to 10. Equilateral, remembering all the sides are the same. So it says find the height of the triangle. We're trying to find h. So we can use either of the 2 little triangles that the big one has split in, the height splits into, because they're both the same. They have the same measurements. And h is a leg. This is a leg, and 10 is the hypotenuse. So h squared plus 5 squared is equal to 10 squared. H squared plus 25 is equal to 100. H squared is equal to 75. H is equal to radical 75, which simplifies to radical 25 times radical 3. So H is 5 radical 3. That's the height of the original big triangle. I'm going to skip number 6, and I'll leave that for you guys to work. And I want to come down and do this guy at the bottom. This is kind of a typical kind of a little bit more difficult two-step kind of problem involving the Pythagorean theorem. So you've got this box, like a rectangular prism. That's a box, means a box. And so this is a 3D figure. So we're looking at not just a length and a width, but we're actually looking at a third dimension here too. And you are going to, they give you some information. So they say the base is 6, and they tell us the base is 6 by 4. So this is 6, the base of this prism, and then this is 4. So that's the base of our prism, and it's 2 feet tall. So we know the h, the height, is 2. You can write it on any side you want, really. So it says they're trying to fit a metal rod along the diagonal of the box. So from the upper corner to the front bottom, they're going to fit a long metal rod, and they want to know what's the length of that rod. What's the maximum length that they can fit? Well, this is actually a two-step problem, because if we think about it, we can draw a diagonal, kind of a, if I can do this on this tablet, like that, and make a right triangle. This meets the bottom. This is perfectly vertical. This meets the bottom at a right angle. And we know the height is 2. That's great. We're trying to find the length of the diagonal, the hypotenuse. We need to know the length of this side, right here, this dotted green line. And we can find that by using the fact that this is also a right angle. And we have this guy right here who's a right triangle. And we have his 2 sides, his 2 legs. So the first thing we're going to do is find the length of the green dotted line. So I'm going to call that x. So we're going to say 4 squared plus 6 squared is equal to x squared. And that's 16 plus 36 is equal to x squared, which is 52 is equal to x squared, or x is going to equal radical 52. And I'm not going to worry too much about simplifying this right now. I'd simplify it if it was a perfect square, but it's not. And I'm just going to plug him in my next problem. So I'll deal with simplifying my radical at the bitter end. So this was our first step. Now that we know that this guy is radical 52 long, we can use 2 and radical 52 in the Pythagorean theorem to ultimately get the length of this diagonal. So that's our second step here. So 2 squared plus radical 52 that we just calculated squared is equal to, I'm going to call him, yeah, he's d, he's not x, he's the diagonal squared. So that's 4, and that's 52 equals d squared, or 56 equals d squared. Square root of both sides, we just want the positive root, so d is equal to radical 56. So I asked myself, are there any perfect squares in there? Well, 2 times 28, no, that doesn't help. 4 times 14, yeah, maybe that one, huh? 4 times 14. So, right, yeah. So this is radical 4 times radical 14, which is 2 radical 14. So that's that one. Let's see. I think I'll go ahead and end this one here and meet you back for the last one. Bye.